Hello, good morning. A very good morning.
Good morning, sir.
Okay then, chalo, let us start with the session. O and all are there. Bushra, A. Malata, Neelam, Sagar, Sharada. Oh, okay, those who are present, good morning and very good morning. Let us start with the session. See, in the today's session, we are going to speak with respect to network analysis. Few of the concepts I'm supposed to teach you. Those concepts I'm going to teach you, and then later we can get into like one problem or two problems we can take, and then thereby we can solve by multiple methods. See, with the help of nodal analysis, with the help of mesh analysis, and like which method we have to use. So these things I'm going to discuss. Now look at the things. See, in the case of network analysis, if I am speaking, you will be having, see, in a few universities, they will be calling it as circuit analysis, and in few universities, they will be calling it as network analysis. So, we have to know what is the basic difference between circuit and network. I hope you are having a brief difference, or you are knowing the difference between circuit and network. If not, let me consider a black box. So, in this, the lines are elements. Like this you will be having. So one particular line is there, no, that is a element. It can be a resistor, or it can be a inductor, or it can be a capacitor, or it can be a voltage source or a current source. See, in the case of circuit, what is the difference between circuit and network is very much simple. In the case of circuit, you will be having the closed path. But in the case of network, see, assume that it is something like this. Nothing but what? From one point you are having a resistor kind of thing, and the other lead is left empty. Nothing but if you are tracing the path, at least one open path should exist. So that is what I mean by a network. In the case of circuit, each and every path is a closed one. Nothing but you travel from here, you can come back to the same point. But you travel from here, you can go up to here. Look at the things. You can go up to here, and then you're going to stop it. So nothing but what? Further things you can't proceed in the case of network. Unable to understand? Don't worry. Let us get into the next topic. See, in the case of networks, especially you are going to make use of elements like a resistor, inductor, and capacitor. Also, you are going to make use of sources. Right? So, especially look at the things carefully. See, the circuit elements or the network elements you are going to study in network analysis, as well as in CMOS VLSI, as well as in analog electronics also. What is the range? That is very, very important. That's it. See, in the case of networks, what will be the resistor range? In the order of ohms. But in the case of analog electronics, you are going to deal in the order of kilo ohms. But in the case of CMOS VLSI, you are going to try to avoid it. Right. Next, in the case of inductor, it will be in the order of Henry. In the case of analog electronics, it will be in the order of milliamperes. In the case of CMOS VLSI, or in the case of this MOSFETs, inductors you are going to avoid. Why? Difficult to fabricate. That's it. And look at the things. In the case of capacitor, see, in a resonance topic, we are going to talk about capacitors also. Or in AC circuits, you are going to speak with respect to capacitors. What will be the range of capacitors? Microfarad. In the case of analog electronics also, what will be the range of capacitors? Means 10 microfarad, 100 microfarad. Sometimes you are going to deal in the case of nanofarad also, and often in the case of VLSI subject, the minimum value of capacitance, the maximum value of capacitance itself is in the order of microfarad. Minimum you can go up to picofarad. So this basic difference we have to know. In like which subject you are studying, what is the range? That's it. So these things are important. Now look at the things carefully. your resistor, inductor and capacitor is depending on others for the supply. Nothing but for operation, you are in need of some supply. It may be a voltage or it may be a current, that is immaterial. So what I mean to say, it is a passive element. What do you mean by passive element? Those elements, like independently can't generate energy on its own. Example, you consider myself like 10 years down the line, I was depending on my parents. Right? Even for food, shelter and each and everything, for fees also, I was depending on my parents. So I considered myself to be a passive element. Right now, many of you may be a passive element. Those who are earning, they are considered to be an active element. So those who are earning, they are called to be an active elements. In detail, what is the significance of passive elements, what is the significance of active elements, what is their behavior, characteristics, each and everything in the detailed lecture I'm going to discuss over there, right? But as of now, you consider that a resistor, inductor and capacitor is considered to be a passive element, and you will be having a sources. You will be having a sources, right? So here the sources may be start making use of running nodes. Voltage source, current source, op amp, BJT, all will be your active elements, right? All will be your active elements. You may be having a confusion that BJT is locally it will be behaving like a passive. Sorry, locally it will be behaving like an active, right? All those things, let us discuss it later, but as of now you consider, in the case of network analysis point of view, resistors, inductors, capacitors are considered to be a passive elements. That's it. And you will be having a voltage source, nothing but it is giving out the voltage. Like a layman language, you remember, that is more than enough. Current source means what? It is giving out current by maintaining constant voltage. What do you mean by voltage source? It is going to give the voltage by maintaining the constant current. Will it be? Let us discuss later, right? The moment you try to connect a load, each and everything is going to vary. Each and everything it is going to vary. Now, in the case of sources also, you will be having a few things, right? What do you mean by ideal sources? What do you mean by practical sources? What do you mean by practical sources? Right now, assume that a person as recruited in a office or in a company. His gross salary is 50,000. His gross salary is 50,000. But he will be getting 42,000 in his hand. Why? Deduction will be there. Why? Deduction will be there. So this 8,000 will be deduction, or it will be deducted by the company. Now, what is his salary? He is getting 42,000. This is a net salary. But in few of the times, especially if you want to do show off, like what is your salary? Like at that time, we will be telling 50,000. Say suppose if a few circumstances will arise where we have to tell the salary very, very less. So at that time, we will not be telling even 42,000. We will be telling less only. Because after deduction only we will be getting, right? That amount only we can spend. So this 50,000 is our ideal salary. This much salary we are supposed to get. But how much we are getting? 42,000. Practically we are getting 42,000. So in the case of sources also, it is the same scenario. Voltage source 50 volts it is supposed to give, but it is giving 42 volts. Current source 50 amperes it is supposed to give, but it is giving 42 amperes. Something like this we can relate. Nothing but there is an internal loss. Here the salary is deducted, but in the case of element there will be a loss. There will be a loss. Why? No one is perfect. No element is perfect. That's it. No element is perfect and no one is perfect. So based on this, so while dealing with the problem or while dealing with the subject, initially we assume that the elements are ideal elements. Later on, practical things we can implement such that confusions will not arise. Right? So while dealing with the problems or while dealing with the subject, initially I assume that the element is ideal one. Next, later on, let us apply the practical things. Similarly, when we are teaching or when we are understanding with the MOSFETs, BJT, op-amp, first thing is we are going to consider ideal scenario and then we are going to analyze. Then practical things we are going to apply. Practical things we are going to apply. Right? Say suppose the exam is conducted for 300 marks. What will be your expectation, or how much you are supposed to get, or how much you are willing to get? You will be telling 300 only. You will be telling 300 only. But practically what will be your expectation? Say suppose if you are getting 220 also, it is enough for us. See, in the marks only we are ready to lose 80 marks. Not an issue. Why? The ultimate agenda is we have to get through the exam. Similarly, the circuit elements losing its ideal nature is not a big deal. Is not a big deal. So we can't expect ideal scenario. We can't expect ideal scenario. Practical things are accepted. Practical things are accepted. Any doubts? Hello? Able to understand with the language?
Yes, sir. Yes, sir.
Okay. Now look at the things. Look at the things. See, we are having voltage source. So some potential we are going to get. So what actually you mean by a term voltage? Next, we have to know what do you mean by current. We have to know what do you mean by power. Right? And we have to know what do you mean by resistance. Resistance. And next part is we have to know what do you mean by impedance. I assume that all these things you know, but advanced thing I'm going to explain as of now. See, these things you're going to apply or you're going to make use of DC circuits as well as AC circuits. In the case of DC circuit, voltage will be there. Say suppose 12 volt if I am telling, how you are going to write what will be the unit? Volts, or it will be capital V. Don't write capital V then a small volts. No, right? So it should be VOLTS or write in terms of capital V. Similarly, what is the unit of current? Turn on the mic and tell me. No, let's see.
Ampere, sir.
Ampere.
Ampere.
Ampere. Good. AMPERE. Or I can write it as capital A. Similarly, tell now what is the unit of power?
Watt,
Watt.
sir.
Okay. The unit of power is watts. Okay. Or I can write it as a W. Capital W. Now you tell me what is the unit of resistance?
Ohm.
Ohm.
Ohms. Or I can represent by this symbol. I can represent by this symbol. Now you tell me what is the unit of impedance?
Mo.
Arey yaar. Impedance also ohm only. Impedance also ohm only. See, the basic difference between resistance and impedance means resistance we are going to tell for which one? DC elements. Nothing but what? There will be no any inductors and capacitors. Right? Whenever you will be having that J term, it can be plus J or minus J. Right? At that time you are going to define in terms of impedance. But the unit of XL and XC will be still in ohms only. Very, very important. I'm going to write and then I'm going to erase. Make sure you're going to make a note of it. See, in the case of voltage, you'll be having the magnitude term. But phase term you will not be having. You will not be having the phase term. Similarly, in the case of current also, you will be having the magnitude term and you will not be having the phase term. You will not be having the phase term. I hope you have made a note of it. I hope you have made a note of it. This is for DC. Next, let me write for AC. Next, let me write for AC. See, you will be having a magnitude term and you will be having a phase term also. You will be having the magnitude term and you will be having the phase term also. What I mean to say, see, it is a 230 volts at an angle of 30 degree. At an angle of 30 degree. Like this also I can represent. At that time, this 230, whether it is a DC value or it is an RMS value, very, very important. Whether the voltage what I specified is a DC value or RMS value or any other thing it can be, right? What it is going to define is very, very important. The moment I get into the subject, each and everything I'm going to teach you, but as of now, you remember that voltage and current in the case of DC, you will be having only the magnitude term, but in the case of AC, you will be having both magnitude as well as phase. In the case of vectors, it is direction, but here it is having a phase. It will be having the phase. Similarly, look at the things carefully. A resistance, I can tell it as a 20 ohms in the case of DC. Right? Impedance, I can tell 20 plus J30. Or I can tell 20 minus J50. Right? Like this also I can represent. Or it can be like, say suppose X at an angle of Y. Rectangular coordinate you are going to specify or polar coordinate you are going to specify, it is left up to you, right? So the basic difference between the resistance and impedance, you please make a note of it, very, very important. You please make a note of it, very, very important. Now you tell me, what do you mean by Ohm's law? You tell me, what do you mean by Ohm's law? Hello, can anyone?
Opposing currents.
Pardon?
Opposing current flow.
Opposing current flow. Opposing current flow. It is a resistance. Resistance is opposing the current flow. I'm asking you Ohm's law. OHMS LAW law. Ohm's law.
V is equal to IR.
Okay. So what actually you are going to tell is a V equals to IR. See, strictly speaking, it is something like this. I equals to V divided by R. If I want to be specific, I is proportional to V. I is proportional to V. Still more specific means that this is not the only form of Ohm's law. Why I told like this means, see, there are 9 forms of Ohm's law. Among that, one of the form of Ohm's law is this V equals to IR or I equals to V divided by R or I is proportional to V. What it says is the current that is carrying in the conductor is directly proportional to the voltage that is being applied. But here, 2 things are maintained. One is at constant pressure. Next one is at constant temperature. Nothing but you are putting a restriction on environmental scenario. At this moment only you will be having, or this condition will be satisfied. Nothing but I is proportional to V. That proportionality, if you are removing, that is, it is 1 by R is the constant. So you will be getting I equals to V divided by R. This is one of the form of Ohm's law, not the only form of Ohm's law. My wordings, you please make a catch of it. I'm going to repeat it again. I equals to V divided by R is one of the form of Ohm's law, but it is not the only form of Ohm's law. Right? You will be having 9 forms of Ohm's law. That slowly when we are getting into the session, at that time I will be teaching what are those 9 forms of Ohm's law. Why it is important. Right? Now look at the things. People may wonder, they will be asking, we are studying all the outdated subject. We are studying all the outdated subject. See, you get into the any industry of your choice, not with respect to the teaching. There you're going to calculate, or you're going to uh, raise the things based on your subject knowledge. Now look at the things, sir. We have applied, or right now I'm working right there. We are going to make use of resonance concept. We should know what do you mean by series, what do you mean by parallel. We should know what do you mean by series, what do you mean by parallel. We should know how to operate multimeter. We should know how to operate multimeter. Like these things are very much important. Like see, people may ask that these things are outdated, but even though it is outdated, it is very, very important. Even though it is outdated, how best you can utilize it is important, right? Now look at the things. What I mean to say is, see, say suppose 230 volts is the input to your house, right? You have light on one bulb. Right? Your power bill is say suppose 100 is the minimum charge, and then you will be getting 20 rupees. So totally your power bill will be 120 rupees. Say suppose next month, complete month, you have used 2 bulbs only. Say suppose, assume that you are connected in series. What will be the power bill? Straight away you should be in a position to answer. Why? You know the concepts of network analysis. Right? Now look at the things carefully. What exactly you mean by series? What exactly you mean by parallel? I'm going to teach you. Right? Often many students will get confused whether 2 elements are in series or not. Like people will get confused. I'm going to give some of the examples. You please make a note of it, and you tell me that which and all elements are in series and which elements are in parallel. Right? Just make a note of it, or you just watch it. I'm going to give 2 resistance R1 and R2 in the first problem. And in the second problem, what I'm going to do is R1, R2. Right? Now, look at the things. In the third problem, what I'm going to do is we are going to increase the complexity. Right? R1, R2, and R3. In the fourth problem, R1, R2, and then you will be having that R3 element also. You will be having this R3 element also. This is R3, this is R2, and this is R1. 4 problems I have given. Start telling one by one. No? In the first case, R1 and R2 is connected in series or parallel?
Series, sir.
Series. In the first case, R1 and R2 is connected in series, right? I'm going to tell you what do you mean by series later, but answer the second one. R1 and R2 is connected in series or in parallel?
Parallel.
Some of the person are telling series and some of the persons are telling parallel. Actually, it is parallel. Why I am going to tell you. In the third one, which elements are in series? You tell me.
R2 and R3 are parallel.
R2 and R3. R2 and
और R1 series में उन दोनों के साथ.
R1 is series in these 2 things. Okay. In fourth one, you tell me.
R2, R3 parallel. R2, R3 in series with R1.
Okay. Now, one person, see, what is the difference between third one and fourth one then? Fourth one is correct means
Hello?
third one should be wrong.
Hello, sir.
Tell me, no?
In third circuit, R3 and R2 not connected.
R2 and R3 not parallel. Why? What is the further thing I have not given? So we should not assume. So my view is whatever they have given, nothing but whatever the author say in a language subject, that itself is final. We should not assume further things. Similarly, in this one also it is the same scenario. Now let me tell you, or let us discuss what exactly you mean by series, what exactly you mean by parallel. For that, let us make use of some wires in order to explain. For that, let me make use of some wires in order to explain. See, an element is here, R1 element. This one is R1. One more resistor I have given, this is R2. Now, look at the things. Person standing next to you is a series. Person standing next to you is series. Person standing in front of you or in back of you is parallel. What I mean to say is either of the element is connected. If this one is connected or this one is connected, only one element, one side you are connecting, the another side is not a common thing. So that means what? It is in series. R1 is in series with R2. Now look at the things. In a similar way, R1 is over here and R2 is over here. Both ends are joining. Nothing but both the terminals are shorting. So now R1 and R2 is in parallel. You answer this one. Let's see. R1 is here. R2 is here. You tell me whether R1 is parallel with R2 or not.
Parallel.
Parallel only. R1 is still in parallel. Like you are getting a confusion, don't worry. I am there to resolve it. See, you consider this one as a left one, this one as right one. You are considering this one as left one and you are going to consider this one as right one. Left is getting shorted with the left or right, that doesn't matter. Right should also get short with the right side or left side. Nothing but both the terminals are common. Both the terminals are shorted. That means what? The elements are connected in parallel. Right? The elements are connected in parallel. Now you please go through this third question. See, in this third question what it says is, look at the things carefully. R1 and R2 are supposed to be in parallel. R1 and R2 is supposed to be in series. But what exactly happened? Between this point, one more tapping was there. One more tapping I have taken. The moment tapping I have taken, whatever the current that is flowing through R1, if that same current will be flowing through the R2, then I can tell R1 is in a series with R2. But here current division is going to take place between R2 and R3. So R1 is not in series with R2. I'm going to repeat once again. Look at the things. In the first problem, you see, whatever the current that is flowing through R1, the same current is flowing through R2. Nothing but they are in the straight line. So if they are in the straight line, then we can tell that the elements are connected in series. If not, I can easily say that the elements are not connected in series. In the second problem, both the sides are getting shorted, or both the sides you will be getting the common elements. So we can tell the elements are connected in parallel. Having any confusions, let us take one more problem. Right? Let us take one more problem. R1, R2. Now look at the things. You will be having this R3 element also. and then you will be having this R4 element. Now you tell me how the elements are connected. Now you tell me how the elements are connected. Hello?
R1, R2, R3 are
R1
series.
series
R1,
Parallel
R2,
to parallel.
and R3 are series.
R1, R2, R3 are in series. What about R4?
It is
R4
parallel to
रेजिस्टेंस
series.
है तो इस इधर शॉर्ट सर्किट है उधर शिफ्ट फ्लो नहीं होगा शायद.
Shayad. Okay. See, look at the things.
कंफर्म कर.
Look at the things. This is the short circuit path. Here, what is the resistance? Shown you, 0 ohms. In the case of R4, some resistance will be there that is not 0. That is not 0. Simple way I will be explaining you. See, if you are choosing this path, you have to pay the course fee 0 rupee. If you are choosing this R4 path, you have to choose, you are supposed to give some fees which is not 0. It can be somewhere like 1000 or it can be up to 10,000, not an issue. Now, frankly, you tell me which path you are going to choose. Same knowledge, same data transfer. One thing is, see, one thing I am going to tell you. If you want to watch a movie, pirated things are there. First one is pirated, and again, nothing a big deal. There will be no any legal issue on you. You are going to choose the first one, or in the second one, you are going to pay some amount, and that will be for a fixed time. You are going to choose the second one. Definitely, we are going to choose for the first one, right? So, similarly, in this case also, this terminal, look at the things. This node, let us call it as N1, and this node, let me call it as N2. They both are same only. They both are same only. It is something like this. Look at the things. R1, R2. This is R3. This is R4. So R1, R2, and this is R3, and this is R4. The current will be choosing this path only. It will not be getting to the R4. Why? A sudden turn only you can take. Why getting into this R4, dissipating and wasting the power? Right? So, always current chooses the least path. Here, there will be no any resistance. Here, there is a huge resistance difference. On the one side, it will be 0 ohms. On the other side, it is not 0. So, 0 will be chosen. 0 will be chosen. Right? In the case of addition and subtraction, your value should not change. So that means what? We are going to add 0 to it. That's it. Or we are going to subtract 0 to it. No change. Now, this R4, I can write it as a redundant element. R4 is considered to be a redundant element. Nothing but what do you mean by redundant? There or not, that doesn't make any sense. R4 element there or not, that doesn't make any sense to the circuit. This is what I mean. R4 present or not, that doesn't make any sense. Still unable to follow? I'll be giving you one example. Today, India versus New Zealand is there. India versus New Zealand match is there. 11 players are there. All players are good one only. Right? Assume that I am playing in a match. I am there or not, that doesn't make any sense for them. That doesn't make any sense for them. Why? I am not in a position to score even a single run. Or I am not in a position to take even a single wicket. Or I am not in a position to control even boundaries also. The moment I throw a ball, like any person, he will be hitting 6 or 4 only. Right? So, I considering or I being getting joined to the cricket means waste only. Similarly, in the case of networks also, some of the elements, sometimes it will be behaving like a redundant. Nothing but what? Those elements can be easily removed. Those elements can be easily removed. If you are keeping no, it is just a waste of time. See, let me consider, in order to build a resistor, like I have to pay a rupee, I have to spend a rupee. So R1, R2, R3, 3 rupees I have invested. R4 again, another 1 rupee I have to invest. So say suppose 1000 replicates I am going to make use means 1000 rupee I am losing. The other person, what he will be doing is he will not be making use of that R4 element. So who will be making profit? That person will be making profit. I will not be in a position to make the profit. Why? Circuit redundancy I am not good. Or I am not good at circuit redundancy. Similarly, look at the things carefully. Look at the things carefully. Given this circuit R1, R2, then R4, R3. How a good person will be choosing means, look at the things. R1, R2 is there. R1, R2 is there. Right? Now look at the things. Here R3 is also there. Assume that the terminals are some like this. At this moment, what you will be getting is, R1, R2 is in series. This entire combination is in parallel with R3. But in the above problem, R1, R2, R3 is in a series only. But in this case, since I have connected the leads, the current that is getting into it has to leave at this point. So two paths it is going to take. One is R1, R2, and the second part is R3. Still not in a position to understand. I'll be giving another one example. Say this is your overhead tank. You're going to make use of water in like some of the rooms, right? This is a washroom. Assume you're going to make use of water in the washroom. This is toilet. You're going to make use of water in the toilet area also. This is kitchen. You are going to make use of water in kitchen also. So the moment you open the tap, water will flow. The moment you open the tap in washroom or in toilet, water will flow. So water is flowing means what? Current is flowing. That's it. Current is flowing. Right? Look at the things carefully. Another example I am going to give. See, pipe is there. Like this, again you are connected a pipe. Like this, again you are connected a pipe. You have made a circular round kind of thing. That makes any sense? No, right? It doesn't make any sense. The moment you construct pipes or something like this, what exactly you are doing means you are losing money. Why? Here one T, here one elbow, here one more T. Assume that it is a 1-inch pipe means, see, if you are going for CPVC means a T cost is 50 rupees. 50 plus 50 is 100. Elbow cost is 20 plus 20. 40 rupees. Total 140 you will be losing. Whether you are going to choose a path something like this, water which is getting into comes back, right? That actually doesn't make any sense. So you are not going to make use of a scenario something like this. So what is the best thing you can do? A circuit given, directly you are going to remove the redundant elements. Now look at the things. R1 and R2 is in series. And this entire combination is in a parallel with R3. Assume that this value will be a total resistance. Now, the person has asked you to construct a circuit. The circuit is something like this. What the best thing you can do is you can construct R1, R2 and R3. What the other person or an intelligent person will be doing is he will be writing a single resistance RT. That's it. He will be representing the single resistance, that is RT. Any doubts? Hello? Right. Now you have understood the elements that is connected in series and in parallel. Now let me give you one example. Sorry. You tell me the answer for this one. Tell me the answer.
First one is 12 ohms, sir.
First one 12 ohms, sir.
Hmm.
Second one 10-20 parallel with the 5 series.
Answer, madam.
Second 20.
How come 20? Tell me what is the answer for the second one?
11 point
The
something.
11.6.
11.6.
6.
This will be 6.6.
11.66.
This will be 6.66. Correct, no?
Yes, sir.
Yes, sir. Yes, sir.
Why I asked you means one conclusion we have to remember, that's it. In the case of series, the total resistance will be larger than the largest. Nothing but this 12 value is greater than 7. This 12 value is greater than 7. I'm going to repeat once again. Sorry. In the case of series, especially resistors and inductor, in the case of series, the total value will be greater than the greatest. Right? Out of 5 and 7, 7 is more. The total resistance should be greater than 7. In the second case, you see 10 ohm and 20 ohm is in parallel. But what is the equivalent value you got? Sorry, 6.66. Nothing but it is less than the least. Which is least? sorry.
10,
Which is
sir.
10. The equivalent value will be less than 10. Less than 10. So this is important. So out of 10 ohm and 20 ohm, those two elements are connected in parallel. The equivalent value will be 6.66 ohms. The equivalent value will be 6.66 ohms. So can I write, in the case of series, you are going to add it. I have written for the general case. Similarly, in the case of parallel, it is something like this: 1 divided by Rp, which is equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by Rn. That's it. So, like this, I can define for inductors also. In the case of inductors, I'm going to represent by L. Inductors connected in series is same as resistors connected in series. Equivalent value is L1 plus L2 plus L3 plus so on to Ln. Similarly, in the case of parallel, 1 divided by Lp, which is equals to 1 divided by L1 plus 1 divided by L2 and so on. In the case of capacitance, 1 over Cs will be given as 1 over C1 plus 1 over C2 plus 1 over C3 and so on. Similarly, in the case of parallel capacitance, C1 plus C2 plus C3. Why it is something like this, I'm going to explain. In the case of parallel, charges gets accumulated. Capacitance value will get increased. The total value of the capacitance will get increased. What is the significance of all these things? I'm going to explain in the session. Now, you are in a position to understand the passive elements. The passive elements when connected in series and the passive elements when connected in parallel. Next thing is, let me consider one problem. Let us consider one problem. You tell me any value of your choice, I'm going to take that value only. What is the voltage value you have to take? You tell me.
10 volt. 15 volt,
Resistance value.
4 ohm,
Hmm.
10 ohm, 15 ohm.
Okay. Now the question is identify or determine the voltage and current through all the resistance. Nothing but what is the voltage across 4 ohm, 10 ohm, 15 ohm. What is the current through 4 ohm, 10 ohm, 15 ohm. That's it. So I'm going to give you a 2 minute of break. You please try to solve it, and then later I'm going to explain you with the help of nodal analysis, with the help of mesh analysis, with the help of superposition theorem. Each and everything we shall apply today. Okay. Hello. Anyone has solved?
Hello.
Tell
I
me now.
got voltage across 4. Current across 4 ohm is 0.4.
Okay. Now look at the
Current
things.
across 4 ohm is hello.
Tell me.
Current across 4 ohm is 2.45 ampere.
2.5 ampere. Okay.
Current across 15 ohm is 1 ampere.
Uh,
And sir, I am confused about 10 ohm resistance.
hmm.
I got two values according to my confusion. 0.2 ampere and or
Hmm.
or 2.5 ampere.
Voltage across 4 ohms. Anybody with different answer, you can tell
10,
me.
10 ohm.
Hmm. Tell me.
Uh, I have confusion about 25 and 5 volt.
Okay.
25 volt or 5 volt.
25.
And
Okay.
15 volt. And across 4 ohm, 10 volt.
This is your answer. Let's see whether your answer is correct or wrong. But before that, let me give you one theory behind this one. Now look at the things. See, resistor R1 and R2 is connected. This is a common point for R1 and R2. In a breadboard you are connected, or in a springboard you are connected, whatever and you want you take. One common point is there. In the second one example, look at the things. R1 is there, R2 is there, then R3 is there. R1 is there, R2 is there, then R3 is there. How many elements are meeting at this point? 3 points it is meeting. How many elements are meeting at this point? Only 2 elements are meeting. So, in both the cases it is a node only. In both the cases it is a node. Where 2 or more elements meet at a point, it is called a node or a junction. So, 2 elements are joining means it is a simple node. Not at all interested because it is simple. Next, 3 or more elements is joining, that is referred as what? A principal node. That is what? Principal node. We are very much interested. Why? Solving nodal analysis or mesh analysis is important. Unable to understand nodal analysis, mesh analysis, don't worry. You know what do you mean by KCL and KVL, that is enough in order to solve any problem that they have given in networks. Right? If you are knowing KCL and just KVL, you can solve the problem. In this problem, what they have given, to find the current values and the voltage value. For that, the prerequisites are what is a simple node and principal node. Again, I am going to repeat. 2 elements joining at a point is referred as simple node. 3 or more elements are joining, it is referred as what? Principal node. Now look at the things carefully. Let me name some of the nodes. Let Let me name some of the nodes. This node I am going to call it as N1, N2, N3. Now look at the things carefully. Slowly observe carefully. Right? Widen your eyes and then you try to observe. Right? This node I am going to call it as N4, and this node I am going to call it as N5, and this node I am going to call it as N6. What is the mistake I have made in representing the nodes? Can anyone tell me? What is the mistake I have made in representing the nodes? Can anyone tell me?
Here is one and only one node, that is Gen 2.
N2. Because N1 is 10.
No. Look at the things, sir. A voltage source is there. 10 volt. Another 4 ohm is there, resistor. What you have done, you have made a connection. This is a simple node. So N1 is valid. N1 is a simple node. Similarly, N3 is also a simple node. Look at N2. It is a principal node. Because 3 or more than 3, it is connecting. So this N2 is referred as principal node. My question is, no need to represent this N4. Why? This circuit is something like this. Any doubt if I am connecting like this? There should be no any problem to you. Simple thing is I have just bent it, that's it. See, instead of wire connecting like this, what I did is I have connected something like this. So instead of connecting wire something like this, I have connected wire something like this. What is the resistance of this wire? 0 ohm. What is the resistance of this wire? 0 ohms. Right? So in this case, N4 and N6 is not a node. In this case, N4 and N6, it is not a node. N4 and N6 is not a node. Very, very important. Now you tell me how many principal nodes are there? The definition of, pardon?
One principal node.
N2 and N5.
N2 is principal node.
What about N5? N5 is also a principal node. See, a wire is there. Instead of connecting like this, I can connect like this also. The only the thing is for understanding purpose and for the beautiness, I have written in terms of a rectangle or square. In networks, there is no beauty. You want to represent resistor something like this, you represent. You want to represent a resistor something like this, you represent. Or you want to represent something like a resistor something like this, you represent. Nobody is there to ask you. Given a problem, if they have asked for 10 marks, right, in your exams, and you have got the correct answer, whether you write neatly or untidily, you'll be getting the same marks only. Why? Problems. Right? You're getting the answer or not is a material. Right? How you connect is not important. So what I can say is N2 and N5 are considered to be a principal node. N2 and N5 is considered to be a principal node. That's it. Now N2 and N5 is considered to be a principal node. N1 and N3 are considered to be a simple node. What I told initially, simple node, we are not at all interested. Why? Simple. It is very much simple to understand, means significance is less only. The thing which is very much clumsiness, we have to put an effort to achieve that. So that matters a lot. Yeah, See, getting a JRF or getting a assistant professor, you require lots of effort. You require lot of effort. So it is very much significant for you. It is very much significant for you. For your daily needs, that much of effort you are not at all spending. For your daily needs, that much of effort we are not at all spending, right? But for exams, we are sacrificing our nights and days. And we are spending lots of money for purchasing books and for buying course, all those things we will be doing. And we will be, moreover, we will be sacrificing our health also. Right? One thing, main agenda is we have to get through the exam. That's it. Right? So, principal notes are considered, but simple notes are simple only. Throw it, not at all interested. Right? Like one more example. If you are not in a position to understand. If I am asking you 1 rupee, you will be spending. Arey sir, take 2 rupees. Arey, you take 10 rupees. The moment I ask 1000 rupees, all of you will deny. All of you will deny. Why? This is a huge value. If I want to get 1000 from you, that means what? Some other thing I have to transfer. A barter system. Right? You give one, I will be giving you the other one. Right? So, principal notes are considered rather than simple notes. Right? N2 and N5 are considered to be a principal note. You can solve this problem with the help of mesh analysis. You can solve with the help of nodal analysis. In a side, you try to make a note of it. Assume that if I am going to make use of nodal analysis, then I'll be making use of KCL equation. Then what I'll be getting is, I'll be getting the voltage terms. I'll be getting the voltage terms. So nodal analysis if I am doing means I'll be getting a voltage term. I'll be getting a voltage term. Directly, straight away I'll be getting the voltage value. Similarly, in the case of mesh analysis or in the case of loop analysis if I am doing, then I am going to get the values of currents. I am going to get the values of currents. Right? Even though I apply KVL, I am going to get the values of current. So, in this problem, what they are asking, whether to find the values of voltages across elements, straight away make use of KCL. If they are asking the current values, straight away you make use of KVL. But you ask any question to me, I am going to apply KCL only. Why? KCL is simple for me. I am going to apply. Then upon getting the result, it is another one line of substituting the answers. That's it. Another 1 or 2 line I am going to take and then I am going to get the answer. That's it. I am going to find out the values of voltages. Voltage divided by resistance. That gives you the value of current. That's it. That gives the values of current. Right? Now look at the things. I have told you that if I am going to make use of nodal equation, then I will be getting the voltage term. If I am going to make use of mesh or loop equation, I am going to get the current terms. Now, let me apply nodal analysis. Next, let me apply mesh analysis. Let us get the answer. Whether we are getting the same answer or not, let us try to find out. But before that, nodal analysis, let us try to find out. Or what is the significance of nodal analysis, or what do you mean by nodal analysis? Let us try to understand. See, this is a traffic junction. You will be having 4 roads. You will be having 4 roads, right? Assume all the roads are one way only. So this road direction is something like this. And on this road the direction is out of. And in this road the direction is into. And in this road the direction will be into. Now look at the things carefully. Look at the things carefully. The currents I1 is entering. Now look at the things. I1 current is getting into. I2 current is also getting into. But I3 current is leaving and I4 current is also leaving. What it says is sum of incoming currents is equals to the sum of outgoing currents. Nothing but in a node or junction, The sum of incoming currents, what are the sum of incoming currents? I1 and I2 is equals to the sum of outgoing currents, that is I3 and I4, is equals to the sum of currents, that is I3 and I4. Important, right? Now look at the things. You can represent in the other way. I told I1 plus I2 equals to I3 plus I4. You send this I1 plus I2 term on the other side. At that time, you'll be getting that I3 plus I4 minus I1 minus I2. Or you send this I3 plus I4 on the left side. So what you will be getting? I1 plus I2 minus I3 minus I4, which is equals to 0. According to this equation, what I mean to say, is the entering currents I am taking it as a positive. Entering currents I am going to take it as positive. But the leaving currents I am going to take it as a negative. Entering currents I am going to take it as positive, and the leaving currents or outgoing currents I am going to take it as a negative, and then I am going to solve. This is not a hard and fast rule. If you are sending all this term on the other side, what you will be getting? Entering currents are negative and leaving currents are positive. However you want, you take, that doesn't matter. Similarly, especially throughout the lecture, how I will be solving is look at the things carefully. This is R1, this is R2, and this is R3. What I told, at the node or junction, sum of incoming currents are equal to sum of outgoing currents. Sum of incoming current is equal to sum of outgoing current. What I will be representing is, I can assume, no problem, all the currents are entering. Or I can assume all the currents are leaving. Or I can assume actual direction. However I want, I can solve. Now look at the things carefully. This node, one of the principal node, you have to connect it to ground potential. Or you have to take that node as a reference node. So one of the principal node need to be considered as a reference node, and that one you try to connect it to a ground potential. Here in this N2 also can be considered to be a principal node. Not only N5, N2 also you can consider to be a principal node. What the thumb rule says is, one of the principal node need to be considered as a ground potential or a reference potential. So I have considered N5 as a reference potential. So what are the remaining principal nodes? Only one remaining principal node is there. That is what? N2. How many nodal equations I can apply? Only one equation. Nothing but how many principal nodes are there? There are two principal nodes. How many nodal equations I can apply? It is one only. Nothing but number of principal nodes minus 1 will be your nodal equation. So in textbooks what they will be giving is NP minus 1. Right? One more formula is there, branches minus node plus 1, that is the minimum equation that you are supposed to get. That is the other one. There you are going to make use of branches also. But here I am not bothered with respect to branches and all. Here straight away what I am going to tell is how many nodal equations are necessary in order to solve a problem. I require only one nodal equation to solve. Why I am not solving with the help of mesh analysis, later part I am going to explain. Right? In the mesh analysis, a minimum 2 equations I am going to write, and then I should solve it. Right? Now look at the things. What I told, one of the principal node need to be considered to be a least potential or the reference potential. Then on the other node, what I will be taking is all the currents are leaving. That's it. All the currents are leaving. That's it. Now, this node voltage, I am going to take it as a Vx. Very, very important. Now, look at the things. See, this is a resistor R1. Here you will be having the voltage V1. Here the voltage potential is a Vx. Here the voltage potential is Vx. If I assume that the current is flowing from left to right, then what is the equation of current? V divided by R. What is R? It is R1. What is V? Difference between the potential. Current flows with the potential difference. See, what is the potential difference? Current is flowing from higher potential to lower potential. What is the higher potential? V1 minus. What is the lower potential? Vx. That's it. Similarly, say assume that this resistance is R1. This potential is Vx and this voltage is V1. I assume that the current direction is something like this. I take it as I2. What is the value of I2? I2 equals to, what is a
Vx minus V.
it should be what? Vx minus V1 divided by R1. Vx minus V1 divided by R1. You think like this. If I2 turned out to be a positive value, important thing. If I2 turned out to be a positive value, nothing but whatever the direction I have taken is correct. Whatever the direction I have taken, it is correct. If I2 turned out to be a negative value, whatever the direction I have taken, it should be opposite. That's it. Nothing but what? I2 direction is not from right to left. Instead, it should have been left to right. That's it. So, like initially you assume something. Later on, if the assumption is wrong, you try to reverse. That's it. You try to reverse. That's it. So, this concept, I guess you are very much familiar. Right? I hope you are in a position to understand this one. Hello? I1 direction,
Yes,
I2
sir.
direction. I
Yes, sir.
is given by V by R. What is V? Potential difference from where to where the current is flowing. That is a material for us. Now look at the things. In this, what I told, I assume all the currents are leaving. You take all the currents are entering. That's it. There is no big deal. Now look at the things. For your understanding, I am going to write all the currents are entering also. But final solution for each and every network analysis problem, whichever you give, I'll be assuming all the currents are leaving only. Why? I'll not be wasting even a 5 seconds of time. Whether I should apply all the currents are leaving or all the currents are entering, or which one is entering, which one is leaving. No, I'm least bothered. See, a good person or the person who has got a grip on networks, he will be assuming this I1 current and I2 current as entering, but I3 current as leaving. Right? Actually, this is the way. This is the thing we have to assume. But I'm least bothered with respect to the potential. Whether it is 10 volt, 15 volts or minus 10 volts or minus 15 volts, nothing. Straight away solve it. Now look at the things. This current is I1. This current is I2. This current is I3. I1 plus I2 plus I3 is equals to 0. Why? Sum of incoming current is equals to sum of outgoing currents. That's it. Now you tell me what is the value of I1. Hello? You tell me what is the value of I1. I1 is flowing through 4 ohm. It is flowing from left to right.
Vx minus 10 upon
Arey
4.
yaar, see, that is the actual thing. But here I'm explaining you by assuming all the currents are entering. When I take all the currents are entering, the
10
current is
minus
flowing from
Vx
10
upon
minus Vx divided by resistance value is what? 4. Plus I2 is also entering. So it is entering from ground potential 0 minus Vx divided by what value? 10.
10.
Plus I assume R3 current is also entering. That means what? 15
15
minus Vx divided by 15
15.
equals to 0. Equals to 0. Right? Now look at the things carefully. Let us write KVL equation for all the currents that are leaving. Tell me the left side current. See, this current I am going to take it as I1. This current I am going to take it as I2. This current I am going to take it as I3. So based on KCL, I1 plus I2 plus I3, which is equals to 0. See, this is case 1 you would consider. This is case 2 you consider. Case 1 don't get merged with case 2. I1 plus I2 plus I3 equals to 0. Tell me the value, tell me the equation for I1. It is what? Vx minus 10 divided by what? 4 plus
4.
Vx divided by 10 plus Vx minus 15 divided by 15, which is equals to 0. Now look at the thing carefully. You take this one as equation 1. You take this one as equation 2. Is one equation 2? No, if you are telling, send all this term on the right side. Then you will be getting 0 equals to some elements that you will be getting, which is same as equation 1. So equation 1 and equation 2 both are same only. Hello? Is it not? Equation 1 and equation 2 both are same only. So either of the method you solve, you will be getting the answer. Whatever and however you want to solve, you will be getting the same. You should get the same answer. Right? So that's the beauty of network analysis. Right? How you solve, nobody is going to ask you. Whether you got the answer or not, that is very much important. Now tell me, what is the LCM for 4, 10, 15? Let's see who will be answering.
60.
What is the LCM for 4, 10, 15?
60.
60. Let us try to find out. 2 2s 4. 2 5s 10. 15. Next again. 5 you can take. 1, 3. Stop it. 2 5s 10, 10 2s 20, 23, 60. Good. 60 is the LCM. Now, many person will be having a confusion how to take LCM, right? Divided by 60, which is equals to 0. See, 4 is there. 60 divided by 4 is how much? 15. So remaining terms are how much? 15. 15 Vx minus 15 times of 10 is 150. Plus out of 60, 10 you have utilized. So 60 divided by 10 will be how much? Another 6 we have to utilize. So it is 6 times of Vx. See, 60 divided by 15. 15 ones, 15 fours. 15 you have utilized. Another 4 you have to utilize. That is 4 times of Vx minus 15 fours, 60. See, 60 equated to 0. So 60 into 0 will be 0 only. So no need to write that divided by that 60 also. Straight away you can write this equation. Right? 15 plus 6 is how much? 21. 21 plus 4 is how much? 25. 25 times of Vx, which is equals to, sending this 150 and 60 on the other side, what you will be getting? 210. What you will be getting is 210. Now you tell me what is the value of Vx. Hello?
8.4.
8.4. 8.4. Unit is how much? Unit is what? Volts. See, straight away I got the value of Vx as 8.4. Straight away I got the value of Vx as 8.4. The rest all the things is drama only. How I will be telling you, see. See, what is the voltage across 4 ohm? What is the voltage across 4 ohm? Right? On the one side it is a 10 volt. On the other side it is 8.4 volt. So the remaining should be 10 minus 8.4. How much? 2.6 volts. See, voltage across 4 ohm is 2.6 volt by assuming the current direction is something like this. So it is it is 1.6 volt. 1.6 volt. But if they are asking what is the voltage across 4 ohm, Whether it is positive, negative, what is the difference? Only that one you have to specify. So it is just 1.6 volt. 1.6 volts. Now you tell me what is the voltage across 10 ohm. Hello? Which is same as Vx, no?
Yes, sir.
8.4 volt.
8.2.
What is the voltage across 15 ohm? On the right side it is 15. On the left side it is 8.4. So it is a 6.6 volt. 6.6 volt. Able to follow? Hello?
Yes, sir.
Yes, sir.
Now look at the things carefully. Now look at the things carefully. See, this is a 4 ohm. This is a 15 ohms. This is a 10 ohms. 10 ohms, 15 ohms, 4 ohms. Now look at the things. I can represent like this also. 10 volt. No need to write the battery. Straight away I can represent with the help of the potentials. This side it is 15 volts. What is this value? Ground. What is this value? That is Vx, 8.4 volts. With this 8.4 volts, what is the current direction? What is the current direction in 4 ohm? It should be from left to right only. It should be from left to right only. And on the 10 ohm, it should be on the down side only. And on the right side, it should be from right to left only. This is actual current direction. But while solving, what I did is straight away I assume all the currents are leaving and then I have solved. What is the current equation for I1? I will be writing Vx minus 10 divided by 4. What is the current value for I2? Vx minus 0 divided by 10. What is the current value for I3? It is Vx minus 15 divided by 15. For that I3 value will be getting a negative value. What do you mean by negative? The actual current direction is opposite to the assumed direction. That's it. Simple thing. So look at the things carefully. What is the current I1? What is the current I1? 10 minus 8.4 is how much? 1.6. 1.6 divided by 4 is how much? 0.4 ampere. 0.4 ampere. Now you tell me what is the value of I2? I2 is how much? 8.4 divided by 10 ohms. It is how much? 0.84 ampere. 0.84 ampere. Now you tell me what is the value of I3? 15 minus 8.4 is how much? 6.6 divided by 15. 2.2 divided by 3. 733. 0.733. Hello?
Yes, sir.
0.7.
0.766.
766. Let's see. See, it is 6.6 divided by 15. 3.
0.44.
Okay. Maybe.
0.44.
Okay. 2.2. 3 2s, 3 2s, 3 5s, 15. Okay. 5 ones, 0.4. 0.44?
0. Yes.
Sorry, I made a mistake. 0.44. 0.44. That's it. You will be getting the answer. This is with the help of nodal analysis. What I have found out, only the Vx value. Rest all the things are substitution only. But the moment you try to solve with the help of mesh analysis, two equations you have to take, that is simultaneous equation, and then we have to solve it. Right? Two equations you have to take and then we have to solve it. See, next is a simple thing. No any change. Only one parameter I am going to change. See, many of you will be making a mistake. I hope you have written these things. Now look at the things. 3 resistors are there. Same value I will be taking. What are those values? 4, 10, 15. This is 4 ohms. This is 10 ohms. This is 15 ohms. Now look at the things carefully. This is here still 10 ohms only. This one I can represent like this, minus 15 volts. Or I can represent like this also, 15 volts. Either one of the thing, if I am doing, both are equal, both are the same. Either you inverse the potential or you just inverse the value. Positive represent as negative, negative represent as positive, enough. Or straight away change the polarity. Both are same only. Both are same only. Right? The moment they give question something like this, many of us will get confused. What should be the KVL equation? What should be the KVL equation? Right? Now look at the things. What I say. See, this node I have to consider to be principal node, and I'm going to convert. I'm going to treat it as a reference potential or ground potential. This is one of the principal node. I'm going to take it as Vx. I'm going to take it as Vx. Having any confusion, this one you take it as some potential, that is Vp. What is the value of Vp? Minus 15. That's it. You'll be getting the answer. Nodal equation you try to solve, try to write Vx minus 10 divided by 4 plus Vx divided by 10 plus Vx minus Vp divided by 15, which is equals to 0. What is the value of Vp? What you are going to get? Vx plus 15 divided by 15. Like this you are going to get. Like this you are going to get. So don't get confused with the things the moment when they have changed the battery potential. The moment when they have changed with the battery potential. Right? This is one thing what I want to say. This is one thing what I want to say. Right? Now let us try to solve the same question with the help of mesh analysis. Mesh analysis. When I will be starting with the lectures, I will not be teaching this much of slowly. Right? This much slowly I will not be teaching you. Right? This is 20 volts. Now look at the things. When I was teaching with respect to nodal analysis, I asked you to take the currents as entering or leaving, or one is entering, the other is leaving. That much of full flexibility I have given you. Similarly, in the mesh analysis also, we will be giving you lots of flexibility. What is that flexibility I'll be giving you is, see, this is a loop. You going to take the current direction as clockwise direction, or you try to take it as anti-clockwise direction, or you take one as clockwise, another as anti-clockwise direction, or you take one as anti-clockwise direction, the other as clockwise direction. Each and every possibilities you have given the choice. You can take however you want, right? So option will be given. Give any question of your choice. I am going to take the current direction as clockwise only. I will be taking it as clockwise. That doesn't mean that you have to take it as clockwise. No, you can take however you want. You can take however you want. Now look at the things carefully. There is one material that is being placed over here. You are sitting on the second floor. One more person is sitting on the ground floor. This element is hanging in the first floor. It is tied to a rope. Assume that you are sitting over here and I am sitting over here. Right? Now look at the things. I have been placed in the ground floor and you have been placed in the second floor. Now the material is somewhere in between. Now look at the things. If you want that material, what you have to do? You have to apply more force when compared to my force. Assume that I have applied 5 newtons of force. You should apply more than that. At that time, the material will be moving upwards. Or The other sense, if say suppose if I'm pulling at a rate when compared to like or a stronger when compared to you, at that time the material will be shifted downwards. The material will be shifted downwards. So similarly, what I mean to say is in a resistor, if I am considering R1, if I1 current direction is like this, if I2 current direction is something like this, I assume that the net current is flowing downwards. So when the net current is flowing downwards means at that time I1 should be dominating with I2, or I1 should dominate I2. That means what? I1 is greater than I2. That means what? For I1 I will be taking it as positive, and for I2 I will be taking it as negative. Nothing but the net current that it will be flowing is actual current, it should be I1, but I2 is opposing. So how much of current is flowing downwards means it is I1 minus I2. But say suppose if the currents are moving upwards, that means what? I2 is the current which will be moving upwards. It has to bear for I1. Then the remaining part of the current will be flowing upwards. The remaining part of the current will be flowing upwards. Able to understand? Hello? Simple thing. You want to do a land registration. You are having 1 lakh rupee with you. See, for land registration, you alone, you are you are spending all your time, and then 50,000 will be the government fee. You are spending 50,000 rupee. But here one broker is there, that is I2. His signature is very, very important for you. He is demanding 10,000. That means what? 50,000 you have spent. Another 10,000 you are going to spend. Nothing but 60,000 you have to spend. Remaining amount, how much you are getting over here? Just 40,000 you are going to get over here. Remaining how much you are going to get over here means just 40,000 you are going to get. Right? If I2 dominates more, if I2 is asking 60,000, whether you are in a position to pass the current or whether you are in a position to get the land registration, no. 50,000 is the government fee, 60,000 is the demanded fee. So, but your budget is itself is 1 lakh. So, you are in a deficit of 10,000. That means what? Circuit is not conducting. That means what? Not able to register the property. So, what is the opposite current? That matters a lot. Another thing is, look at the thing. This is a resistor R1. Assume that the current direction is something like this, I1. The current entering the terminal is always at higher potential, I1, and the other one is less only. Why? Assume that the potential over here, it was 10 volts. The moment it has get into resistor, nothing but there will be a loss. How much loss? Say suppose 1 volt is a loss. That means what? 1 volt is a drop across the resistor R1. So only I have represented plus and minus. Now while writing the equation, if I am traveling from plus to minus, I'll be taking it as positive. If I am traveling from minus to plus, I'll be taking it as negative. You want to reverse it, you reverse, no any person is going to ask you. What I mean to say is plus to minus you take it as positive and minus to plus you take it as negative. That's it. Now look at the things. Here the potentials are minus and plus. Here the passive elements are there. Those potentials you have to mention. Plus minus plus minus. Now this current is I1. You can zoom it. This current is I1. Now let me apply the KVL equation for I1. I am over here. I am traveling. I have passed through 10 volt. minus to plus if I am going, then it will be positive. So I'll be writing it as a plus 10. Plus 2 minus if I am going, then it will be minus. Voltage drop across the resistor is given by current multiplied by resistance. What is the value of resistance? 4. What is the value of current? I1. Next, current is flowing from plus to minus. Plus to minus means what? Minus we have to represent. Next, what is the resistance value? 10 into. Now, I1 current is pushing downwards. I2 current is pushing upwards. I2 current is pushing upwards. But the net current is flowing downwards. So, it is I1 minus I2 which is equals to 0. Similarly, you try to apply KVL equation for the second equation. You try to apply KVL equation for the second equation. What you are going to get? Plus 2 minus means what? Negative, minus 20. Plus 2 minus means what? Negative, minus. What is the resistance value? 10 into. What is the current? I2 is flowing upwards, I1 is flowing downwards, but the net current should flow upwards only. So it is I2 minus I1. Plus 2 minus means what? Minus Vx. Sorry, minus 15 times of, minus 15 times of. What is the current? Same direction, I2, which is equals to 0. Call it as equation 2. Arrange equation 1 and 2, then you will be getting the values of currents. Can anyone tell me what will be the value of current I1? Can anyone tell me what is the value of current? The same current that will be flowing through 4 ohms. How much current that is flowing through 4 ohms? 0.4 ampere. What is the value of I2? It is a minus 0.44. It is a minus 0.44. Why I have taken it as minus 0.44? Look at the things. I3 value direction is opposite of I2. Here, whatever the I2 value I have taken, it is opposite of I3. So, the value of I2, in this case, it is minus 0.44 ampere. Very, very important. Like this, you try to find out the values of current. Then, next thing is, straight away you can find the voltages. That's it.
यहाँ पे I1 I2 डिफरेंट आएगा ना, वहाँ पे 15 वोल्ट है, यहाँ पे 20 वोल्ट लिए हो आप इस.
Okay, sorry, it is 15, right? Sorry, 15. 15. Good. That's it, right? I hope I have not made any mistake. So, like this, you are going to solve and then you are going to get the answer. Right? Now, what is the voltage across 4 ohm? You know what is the current across 4 ohm? Multiplied by, you know what is the resistance in 4 ohm? Is 4 only. What is the current through 4 ohm? It is a 0.4. What is the resistance? It is 4. Right? Like this you are going to calculate. Right? Any doubts? Look at the things. I4, how much? 0.4 into 4. What is the voltage across 4 ohm? It is 1.6 volts. It is 1.6 volts. In the previous problem, you see, it is 1.6 volts only. It is 1.6 volts only. Similarly, you will be getting the voltages across 10 ohms and you will be getting the voltages across 15 ohms also. So, why I have solved all these things? Why I have wasted 40 minutes of time is, a simple thing is, whether to apply nodal analysis or whether to apply mesh analysis, or should I solve using superposition theorem. Superposition theorem means what? 10 volts I am using, 15 volts make it dummy. 15 volts if I am using 10 volts, you make it dummy. So, in the first case and second case, you try to find out the individual currents and individual voltages. You try to add, that will be the net voltages. Right? See, simply to confuse you, they will be asking you like with the help of superposition theorem, find the node voltage that is across 10 ohm. We should not apply superposition theorem. You can solve using mesh analysis, or you can make use of nodal analysis. I personally make use of nodal analysis because like 10 seconds more if it is taking, that is not necessary, but I'll be getting the correct answer, right? Why? I may be good at nodal analysis, you may be good at mesh analysis, right? One analysis you try to be master, the rest of the things is left up to you. On the spot, how you are going to solve matters a lot, right? So I have explained the concept, or I have explained the problem, and I have shown you the solution by applying nodal analysis and by applying mesh analysis. In the nodal analysis, the current direction, all the currents are entering, all the currents are leaving, and some of the things are entering and some of the things are leaving. This method also I have taught you. Next, in the case of this mesh analysis, currents clockwise we have to take, or anti-clockwise you have to take. One clockwise, one anti-clockwise, one anti-clockwise, and one clockwise. I have taught you. You just make a note of it, right? Any doubts with respect to nodal analysis and mesh analysis?
No, sure.